Welcome to Harris Academy Beckenham. My name is Mr. Fosu, the Maths Coordinator. It's my pleasure to introduce to you Sixth Form Maths team. They are Mr. Chong, who is in charge of Key Stage 5, Miss Brown, and Mr. Ford. Let's have a look at what we are offering at HAPE. For both A-Level Maths and Further Maths, 3 components will be taught over 2 years. They are Pure Mathematics, Statistics, and Mechanics. For Pure Mathematics, you'll be studying the different methods and techniques which underpin the study of all the other areas of mathematics, such as proofs, algebra, trigonometry, calculus, and vectors. This is an extension of what you have been doing at GCSE level. You have done a little of statistics in GCSEs, looking at how data are represented in cumulative frequency diagrams and histogram. For the next 2 years, you'll be diving deeper and will be calculating the likelihood of an event occurring and reaching conclusions from data. Hypothesis testing will be tested using the binomial and normal distribution. For mechanics, do you remember your velocity time graphs in GCSE? You'll be combining those with what you have learned in physics and learn how to model the motion of objects and the forces acting on them. For HAPE, we'll be using the OCRA MEI exam board. To do A-level mathematics, you need a minimum grade 7 at GCSE. The content will be assessed in 3 2-hour written examination. Paper 1 is pure mathematics and mechanics, paper 2 is pure mathematics and statistics, and paper 3 is pure mathematics and comprehension. The first 2 papers has a weighting of 36.4%, whilst the third has a weighting of 27.3%. Of course, an A-level maths is not required for every university degree course, but you might be surprised at how many courses mention needing having strong math skills, and so having A-level maths is particularly useful. A-level mathematics is also essential or desirable for a wide range of degree courses, including economics, computing, social sciences, and business. According to research by UCL, students with an A-level in mathematics are more likely to attend a Russell Group university. Let us turn our focus on further maths. We'll be using the OCR exam board. The content will be assessed in 1.5 hours written examination. Paper 1 and paper 2 is pure core mathematics. In our school, we'll be offering only statistics and mechanics. Hence, paper 3 is statistics, paper 4 is mechanics. Each paper has a weighting of 25%. This is the course for students with a passion and desire to take maths to the highest level. It's designed to stretch and challenge mathematics students and prepare them for university courses in maths and related quantitative and scientific subjects. It's a challenging qualification which both extends and deepens your knowledge and understanding beyond the standard A-level mathematics. Students who do it often say it's their favorite subject. If you're planning to take a degree such as engineering, sciences, computing, finance or economics, or perhaps maths itself, you benefit extensively from taking further maths. Further mathematics qualifications are highly regarded and are warmly welcomed by universities. Students who take further maths are really demonstrating a strong commitment to their studies, as well as learning mathematics that is very useful for any mathematically rich degree. Some prestigious university courses require you to have a further mathematics qualification, and others may adjust their grade requirements more favorably to students with further maths. Let's have a brief look at the maths book of a typical student at HAPE. In this book, notes are taken down meticulously. This student has taken down in detail a question modeled by the teacher. We emphasize a lot on mathematical presentation as the exam boards place a heavy emphasis on this. Every week, our math students will have to take a weekly test. To do well for the test, they have to understand, revise, and recap what was taught in the previous week. From here, we can see that important notes has been printed out to summarize an important topic. Also, extensive usage of the Casio graphic calculator is incorporated in the lesson. The students will be taught how to make use of it to check their answers and maximize their scores in the exams. We also have an accompanying maths taster lesson for you. Please watch the following introductory video and work on the interactive decimals activity, which you can complete at home.
This video and the accompanying Desmos task provide an introduction to the mathematical topic of infinite series. This is studied by anyone who takes A-level mathematics and is usually covered in the second half of the course. One of the great things about mathematics is that ideas that might seem abstract often have significant applications. Consider, for example, the function y equals sine x. The first person to draw this graph probably did so because they were interested in the mathematics. But subsequently, sine waves have been used to model anything that has a periodic nature, such as the movement of tides and ultrasound scans. Think also of the vast amount of data that is sent using electromagnetic waves, and you can begin to see that actually the sine curve underpins so much of modern technology. Every piece of mathematics that you study at A-level will have many and varied applications. However, for many people, the joy of mathematics is being able to explore ideas that are seemingly abstract. Take the concept of infinity. Most people would probably be quite happy with this statement, that 1/3 is equal to 0.33333 recurring for infinity. However, if we multiply through by 3, we get a statement that some people find quite unsettling. Can 1 really be the same as 0.9 recurring? When you start to look in depth at infinity, which is something you will do a lot at A-level, you do often get some surprising results. Let's look at another example. Here I have a frog who can jump 1 meter in length. However, in making this jump, the frog becomes tired, so its next jump is limited to only half a meter. Each subsequent jump is halved in length. What is the total distance that the frog can jump from its starting point? You will probably be able to see that the frog is going to get closer and closer and closer to 2 meters. But does it ever actually get there? The gap between the frog and the 2 meter mark will continue to reduce over time with each jump. If that gap becomes infinitely small, can we say that it doesn't exist at all? You will have the chance to explore this problem further in the accompanying Desmos activity. For now, I will leave you with another surprising result. Imagine having a shape that begins with a square measuring 1 meter by 1 meter. To that square I add another square with a side length of half a meter, and then another square with a side length of 1/3 of a meter, and then 1/4 of a meter, and so on, infinitely adding increasingly smaller squares. What would be the area of the resulting shape? What would be its perimeter? You might like to pause the video at this point and think about that question before I go any further. The result of this question might be surprising. As we can see, the shape is growing infinitely, and its total perimeter will also continue to grow infinitely without limit. However, despite the fact that it continues to grow and grow and grow, its area never gets bigger than 2 square meters. In other words, here we have a shape that has a finite area but an infinite perimeter. How can that be possible? By working through the accompanying Desmos activity, you will learn some A-level mathematics that will enable us to prove this surprising result.